The network lifecycle involves two important scenarios: new network construction and network maintenance. There are two problems for the two scenarios. During the commissioning of a newly constructed network, the communication quality at the current frequency is poor after microwave link parameters are configured according to the network plan. During network maintenance, the microwave link quality is poor and the link needs to switch to an available frequency. The Optix RTN360 provides two functions to solve these problems, which are interference check and dynamic frequency selection. Interference check is used to check for interference on microwave links, which will result in poor link quality. Dynamic frequency selection is used to dynamically switch to an available frequency after link interference is identified. The advantages of dynamic frequency selection are as follows. Dynamic frequency selection frees you from frequency planning. You only need to select a country name or configure a frequency range, so the dynamic frequency selection will be executed within the band supported by the country or within the configured range. Frequency switching is completed automatically, which reduces maintenance workload. Interference check can be manually enabled in scenarios where a network is being constructed, or in scenarios where microwave links are not restored after dynamic frequency selection is enabled. The interference check process is as follows. A user mutes the slave device through the NMS. The slave device starts the timer. After interference check is started, the master device scans frequencies, starting from the lowest frequency at a step of 200 MHz channel spacing within the entire band. After the timer expires, the slave device is unmuted. After the frequency scan is complete, the master device outputs results indicating whether there is interference on any frequency in the band. The following describes the dynamic frequency selection process triggered by an MWLOF alarm on the slave device. The dynamic frequency selection process triggered by other alarms is similar. After the slave device generates an MWLOF alarm, it is muted. The slave device performs an interference check to obtain the available frequency list and meanwhile determines the transit frequency of the master device. After the slave device is muted, the master device generates an MWLOF alarm. The master device then performs an interference check to obtain the available frequency list. The master device switches to a new available frequency F1 and transmits services to the slave device. The master device also attempts to receive services from the slave device at F1. After identifying the transmit frequency of the master device, the slave device switches to the new frequency F1 to receive services and then unmutes the transmit port. After the master and slave devices receive services from each other, the microwave link recovers.